You know that feeling when your game lags? When your character freezes, then suddenly teleports 20 feet forward because the server can't keep up with reality? That's a glitch in the code. A hiccup in the simulation. Now imagine the universe does this. Not in a game. In real life. In 2019, astronomers confirmed that near certain black holes, time literally buffers. 1 hour for you equals 7 years on Earth. The universe's frame rate drops to near zero. We've measured atomic particles rewriting their own history based on events that haven't even happened yet. Effect before cause. The universe isn't broken, but its source code is definitely showing cracks. And today we have the receipts. Peer-reviewed, verified anomalies that prove reality is occasionally skipping a frame. But to understand how the universe's clock breaks, we first have to look at the massive lag zones scattered across our galaxy, starting with a 4-million-ton monster sleeping at the center of the Milky Way. At the center of the Milky Way sits Sagittarius A, 4 million times the mass of the Sun. Around it, time doesn't flow, it crawls. Einstein proved this in 1915. Gravity doesn't just bend space, it throttles time. Near the event horizon of Sagittarius A, 1 hour of your subjective experience equals 7 years of Earth time. This isn't science fiction. It's mathematics, confirmed by our own GPS satellites and atomic clocks. Think of the universe as a computer rendering reality in real time. Every frame requires processing power, but near a black hole, gravity demands so much computational power that the local renderer slows to a crawl. The star S2 orbits so close to Sagittarius A that every 16 years it loses measurable microseconds relative to us. But the real horror is at the boundary. If you watch someone fall toward a black hole, you would see them freeze. Literally. Their clock stops. They become a permanent, static image, locked at the boundary between 1 second and the next. Space can freeze time, but that's just a local rendering issue. What happens when the universe's network topology breaks so badly, it starts replaying the exact same cosmic explosions like a broken GIF? In 2016, astronomers witnessed something impossible. A star exploded. 3 years later, in 2019, the exact same star exploded again. Same supernova. Same light signature, same stellar corpse detonating. The star didn't die twice. The universe just replayed the footage. When light passes near a massive object, gravity bends its path. But different paths have different lengths. Light traveling the short route arrives years before light taking the long route. Imagine sending an email, but due to server issues, it takes 3 different routes through the internet. The recipient gets it in 2020, then again in 2023 when the slower route delivers, then again in 2023 when the slower route delivers, then again in 2025. Same email. 3 deliveries. This is gravitational lensing. The universe's network topology is causing time-delayed duplicates. The Einstein cross shows the exact same quasar 4 times simultaneously, but each image is from a different moment in that quasar's history. You're looking at its past, present, and future all at once. It's wild enough that light can be delayed by space geometry, but it gets terrifying when we realize that a decision you make in the future can literally reach backward and rewrite the past. In video games, you can save your progress, play forward, reload the save, and change what happened. The future gets erased. The delayed choice quantum eraser experiment, perfected in 1999, proves that a decision you make in the future changes what happened in the past. When you fire a photon at 2 slits, it goes through both simultaneously as a wave. But if you add a detector to see which slit it went through, the pattern disappears. It acts like a solid particle. It chooses one path. Here is where causality breaks. Scientists delayed the choice. They let the photon hit the screen first. Its behavior was already determined. Then, 8 nanoseconds later, they chose whether or not to measure which path it took. The moment they chose to measure it, the photon reached back through time and changed its past behavior. It unwrote its own history based on a future observation. If the subatomic world can process time backward, what about the giant cosmic clocks we use to map the universe? Because right now, the most precise clocks in space are starting to desynchronize. 24, no reason at all. Neutron stars are the universe's atomic clocks. They spin with such perfect regularity that astronomers use them as cosmic GPS. Some pulsars are more stable than Earth's best atomic clocks, predictable to within nanoseconds per year, until they glitch. In 1969, astronomers observing the Vela pulsar watched it suddenly speed up. No warning, no external cause. The rotation period just, jumped. For an object spinning 11 times per second with atomic clock precision, that's like your computer's system clock suddenly jumping ahead by a year for no reason. Vela has glitched over a dozen times since. The Crab pulsar does it every few years. We have theory starquakes, superfluid interiors, but the math doesn't balance. Some glitches even slow the pulsar down, which standard physics cannot explain. We are watching the universe's internal system clock stutter in real time. But what if the clock isn't just stuttering? What if there are massive regions of space where the universe decided to save processing power by turning time completely off? In 1901, astronomers discovered a hole in the universe, a region of space 330 million light-years across containing almost nothing. The Booth's void should contain roughly 10,000 galaxies. It contains 60. It is empty. Not space between stars empty. Not space between stars empty. Empty like the universe forgot to render this chunk empty. Time exists because things change. Entropy increases. Matter interacts, but in a massive void with no matter and no energy. Time loses its functional meaning. Imagine a video game where time only progresses for rendered chunks with active players or NPCs. In empty chunks, the engine pauses time to save processing power. The Booth's void might be exactly that, a massive, unrendered zone where the universe's clock is idling, waiting for matter to spawn. If the universe is saving processing power in the voids, how does it handle communication between particles separated by billions of light-years? It uses a latency cheat code that shouldn't exist. In 2022, the Nobel Prize in Physics was awarded for proving something Einstein called spooky action at a distance, quantum entanglement. Two particles linked such that measuring one instantly determines the state of the other. No matter the distance, no signal, no delay. Einstein hated this because the cosmic speed limit is the speed of light, 299,797.92 kilometers per second. Cause and effect must be separated by time. But entanglement bypasses spacetime's latency entirely. Imagine playing an online game with someone in another galaxy with exactly 0 bms ping. Not low ping, 0 ping. Your actions are synchronized perfectly, violating local realism. The universe shipped with this game-breaking bug realized it too late and patched it. You can't use entanglement to send messages because the results are random. The exploit is patched, but the underlying code glitch remains visible. Space latency is 0, but remember, space and time are interchangeable. If entanglement connects points instantly across space, it means the universe might also have 0 ping across time itself. And the ultimate proof of this is hidden in the oldest photograph of our cosmos. In 1965, we discovered the universe's oldest light, the cosmic microwave background. The baby photo of the cosmos from 13.8 billion years ago. According to the standard models of the Big Bang, this map should be perfectly smooth and uniform, but the file is corrupted. First, there's the cold spot, a massive region of the sky that is significantly colder than everything else for no statistical reason. It looks like a collision echo from a parallel universe or a corruption in reality's initial setup file. Second, there's the axis of evil. The largest temperature variations in this ancient radiation are perfectly aligned with Earth's orbital plane. This is statistically impossible. This light predates the Earth by 9 billion years. There is no physical mechanism for the edge of the universe to know about our address. Yet the correlation exists at 99.7% confidence. It looks like insufficient resolution at cosmic scales procedural generation algorithms cutting corners where they thought no one would look. 7 glitches. 7 places where reality's operating system breaks, lags, or corrupts. These aren't philosophical thought experiments. They are measured, verified, peer-reviewed anomalies. Either our physics is completely incomplete, or reality is a simulation running on finite computational resources, and we are finally seeing the limits of its rendering engine. But everything we just covered about space-time glitches is completely useless if you don't understand how scientists are using these exact anomalies to calculate when our simulation might actually end.